Hi guys, I meant to come out and hang out with you today, but I'm not feeling so good, so I'm going to stay in Seguin. Wanted to give you some notes about Fibonacci Nim, especially since there's definitely going to be questions about Fibonacci Nim on the Chapter 2 exam. Okay, so the first thing is that the optimal strategy, the winning strategy, is to always take the smallest Fibonacci number in the sum. You can't take the medium one or any of the ones in between. It has to be the lowest one. So here's an example of a 17-stick game, and as you know, 17 is 13 plus 3 plus 1. Okay, so what if player 1 took 3 sticks? You might think, well, player 1 could take 1 or 3 sticks and still win. So here's the thing, if player 1 takes 3, then player 2 has 14, right? And 14 is 13 plus 1, so player 2 is going to take control of the game by only taking 1 stick. Player 1 gets a Fibonacci number's worth of sticks, player 1 loses. Very bad. And I think you know, I saw on the homework, if you receive a Fibonacci number's worth of sticks, you are very likely, I think you're guaranteed to lose. If you can force player 2 to receive a Fibonacci numbers of sticks, that's what you want to do. You definitely win. So, okay, you might think, something that I noticed was why shouldn't player 1 take 4 sticks and make player 2 have 13 right away? Seems like something that might work. Well, okay, so if player 1 took 4 sticks, then player 2 is allowed to choose anywhere from 1 to 8 sticks, right? But something that you guys already know is that you can't take more than a third of them. So you definitely don't want to pick more than 4. So there's 4 valid choices, 1, 2, 3, or 4 sticks from here. If player 2 takes 1 stick, then player 1 gets the advantage because 12 is 8 plus 3 plus 1, and player 1's just going to take 1 stick. Okay, if player 2 took 2 sticks, the second case, well, then player 1 still has the advantage because 11 is 8 plus 3, and they could pick 3 sticks legally. The third case is if player 2 took 3 sticks. Well, 10 is 8 plus 2, so player 1 could pick 2 sticks and still win. And finally, if player 2 took 4 sticks, well, 9 is 8 plus 1, so player 1 could take 1 stick and still win. So this is kind of a long solution, right? But we could still prove that player 2 is guaranteed to lose in this case. So that's very strange. It's very strange that instead of taking 1, we took 4 and we still had the advantage. But the problem is that this doesn't always work. Here's a larger example. What if we were playing a 136 stick game? And 136, I picked it because it's equal to 89 plus 34 plus 13. Those are all Fibonacci numbers, non-consecutive. So the ideal strategy says pick 13, right? Well, what if player 1 was trying to speed up the game and they said, I'm going to be smart and I'm going to take 47 sticks? Well, the problem is that maybe you notice that 47 is higher than 1/3, and that means that player 2 can take all of the sticks and win. So in this case, 47 is not a valid move. You have to take the 13. And like I talked about before, 34 is definitely not going to work because then player 2 could beat player 1. And so there's some secrets about Fibonacci Nim. If you like, we'll open up homework 2.2 again and accept rewrites for up to 1 week from today. I'll take care of that in Canvas. Make sure you email me if you have any questions, and I'll see you soon.